Thank you for joining Moderna's webinar on the benefits of using grading optimization for Civil 3D. My name is Salome Fourie, and I'm the Civil Infrastructure Accounts Manager. Presenting today is Andrew Himan. Andrew is one of our applications engineer and part of the Moderna infrastructure team. Please direct all your questions to the Q&A box, or the questions will be answered at the end of the presentation. This webinar will be recorded and will be emailed through to you shortly after the webinar. If you have missed any of our previous webinars, you're welcome to visit our Moderna YouTube channel. And for any other queries, you're welcome to email or contact me. My details will be in the chat box. Andrew, over to you.
Thank you, Salome, and welcome everyone. Okay, so thank you for joining today's webinar. So just to quickly go over some of the contents that we're going to be covering during this session. So as the title says, we're going to be looking at the benefits of grading optimization for Civil 3D. So firstly, we're going to just start off with a quick introduction to what grading optimization is and what it does. And then the main goal of this webinar is going to be looking into a recent productivity study that has been done by Autodesk to look at the main benefits of what this software add-on provides. We're then going to be going through 5 main design tasks or 5 design aspects of site design when looking at grading. Firstly, the mass site grading. Then we're going to be looking at the building pad and parking lot, then the retaining walls, then the attenuation pond and storage volumes, and then just to look at how all of these tie in together when using them. So firstly, we're going to have a look at each one of them individually, not in relation to any of the other design tasks, and then we're going to have a look at the entire design done from beginning to end, and then just to look at the final results. All right, so let's dive into this. So firstly, just a quick introduction. So some of you might be wondering, what is grading optimization? So it's actually one of the newest additions to the Autodesk suite of software. It's actually an add-on to Civil 3D, and it is also included in the AEC collection, as well as the enterprise packages. All right, so basically what grading optimization is that it's an interactive tool. It's used to streamline and also simplify your grading designs. All right, so you all might be, or should by now be familiar with the standard Civil 3D grading creation tools. And some of you might also be aware that it does tend to become a little bit tedious in some parts. This is where the software, where this piece of software comes in. It's there to basically alleviate that kind of tediousness and stress that goes hand in hand with manual grading creation. All right, so it is used to basically streamline these designs for areas such as parking lots, attenuation ponds, and as well as building pads. Okay, so how the software works is that it utilizes surface manipulation. So you would, for example, have a survey in your drawing, and you would then have these footprints of your site and your building pads and so forth drawn out. So what grading optimization does is that it uses, or it manipulates these surfaces by using iterative processing. That means that it uses step processing, going through a multitude of different steps. It can vary into go into the tens of thousands of different iterations to basically find the best fitting design for your site. Okay, and this design is then shown through something called feasibility convergence plotting. I will be showing a little bit what that looks like, the type of output that you get from that. All right, so due to the iterative nature of this software and the way in which it calculates your gradings, you do get a better overall outcome. This is mainly due to the fact that it runs through thousands and thousands of different changes to your site features. For example, slopes on your boundaries, site slopes, drainage areas, and so forth. And this will then give you a much more balanced design at the end of the day. Okay. Then just going into an overview and just some of the key findings that is basically, or how this productivity study was set up. So it was commissioned by Autodesk in 2022, and it is just set out to prove two different points. Firstly, the amount of time saved in these processes. Now, we're not going to be going too deep into each of these processes and the workflows included in that, but we are going to be looking at it in general. So basically, we're going to be comparing the time saved as well as the design accuracy when comparing the new grading optimization toolset to the existing standard Civil 3D grading tools, which we are mostly all familiar with. Okay, so basically for the first 4 steps, those are going to be testing the individual workflows. Those areas all amount to approximately a 10-acre development. Okay, and then when doing the combined workflow, that's the overall site with all of these aspects in the first 4 steps included in them, and all of them are based on each other. Your building pads are based on your overall site grading, your parking areas based on the overall site grading, and also your attenuation point. So basically all of these fitting in together will be a total of 16 acres, just to give you guys a rough idea of the size of development that we're actually working with. Okay, so let's have a look at design task 1. So this is the mass site grading. So basically this is just the overall pad. So imagine you have a site, the site has a wall boundary or just has an outer boundary. And this is basically now just to get an overall pad before any of the other aspects are created. So this is usually before your parking lots and building pads and those types of things are added into your design. So this is also done to even out the site pad as well as create a general drainage aspect to our site. All right. So basically when setting up these aspects as seen on the side over here, the entire site slope is said to be not more than 1 in 4, that is rise over run. That is a 25% site slope. So it cannot exceed that. It can be anywhere between 0% and 25%. And then the tie-in gradings of the pad, that is usually your cut and fall slopes, are not steeper than a 1 in 2 or a 50% slope. So that's your cut and falls. And then also just as a general on this building pad or on the site pad, the area near the gradings and the final positions were limited to approximately, to not exceed a 2% slope. So just to quickly go back to that convergence plotting that I was talking about earlier, this you will see over here. So as you enter your parameters for your site, you basically just have a polyline drawn out. You enter your minimum, maximum slopes, and basically then just run it. And as you can see on this log chart, the convergence plots log chart, it runs from a high convergence, and the more iterations it moves through, you'll see it physically changing your contours, updating the slopes, updating the elevations in this interactive viewer. As it goes through more and more and more iterations, this convergence plot smooths out up to a point where it cannot be balanced any further. Okay, so you do have an idea of when the software reaches its final conclusion, and you can also then see, how can I say this, where it ends and how it's balanced out. So just as a general idea, also the software, when doing the study, the software was set to run at, I believe it was 25,000 iterations. Okay, so a lot more than what you could do by hand. And that also just gives you a little bit of perspective when you're looking at the amount of time saved to get to this point. So when doing this design using the standard Civil 3D tools or the standard grading tools in Civil 3D, to get to a fairly acceptable design, it took around 20 minutes and 51 seconds, as shown in that little box at the left. But when doing this process with grading optimization for Civil 3D, I believe this ended at around 3,000 iterations. It took 4 minutes and 25 seconds to get to a balanced design. All right, so that is just to get to the adequate slopes, to get to the to not exceed those slopes and to get as good of a drainage line as possible. So the total productivity gain that we're actually looking at for this for this process is 16 minutes and 21 seconds. That is just to give you guys a rough idea of how much time this process can save. So that is a productivity gain of approximately 78% when simply looking at this one aspect. Because as we all say, time is money. And this software does save you a lot of time. So that's it for mass site grading. So we're going to move on then to design task 2 to have a look at that. Now in this instance, the building pad and the parking lot were done individually. So basically, just looking at this specific process. So it does include the finer grading aspects of the site, and it is heavily impacted by drainage design. So we do need to take that kind of aspect into account. So just to give you guys an idea of how this was set up, the building pad was graded as a flat or 0% surface. So we have a 0% surface or slope all throughout our building pad. And it was basically set up to not be done with an elevation. So in the box that was prompted, basically just said no elevation. So the software can then decide what elevation to place this at. Then the parking lot, which was next to that, was graded away at a 2% maximum slope from the building pad to prevent drainage towards the building. And what then happens is after this process, this iterative process is run and it obtains its final design, what would happen is your polylines would then be converted into feature lines. So basically looking at this would be your building pad feature line. It would have been applied now in elevation. It would be, all of the edges would be the same elevation. It would be at a 0% slope all around. So you can then just go and select all of these values and update it to an elevation which you feel comfortable with to test that out. So when doing the building pad and parking lot gradings with the standard grading tools in Civil 3D, it took around 33 minutes. But when using the grading optimization tool for Civil 3D, it took 4 minutes and 10 seconds. That equates to a total productivity gain of 28 minutes and 50 seconds. That is around 87% productivity gain when looking at building pad and parking lot design. Okay. And as we all know by now, the grading optimization does run through thousands and thousands of iterations to provide a more accurate design. Then moving on to design task 3. That is where the guys at Autodesk went and did their retaining walls. So basically, they just placed a retaining wall where there was a higher elevation difference between the two gradings, or between any two gradings. They went and added retaining walls. So this is done to provide safe drainage as well as a transition effect between two different grading elevations. And this process is, even when you use the standard Civil 3D grading tools, it doesn't take too long. As you can see there, it took around 5 minutes, 53 seconds, and we saved around 1.5 minutes on that. That's around 24% time saved when doing retaining walls. Now, 24%, I mean, you'd rather look at the 1.5 minutes. It doesn't save too much time, but it's a much simpler process. Okay, and as you can see there, that is the type of interface that you would get when using the grading optimization tool for retaining walls specifically. It would ask you for a maximum height and minimum height. You would draw a little grading boundary so that the grading cannot exceed past that. Okay, so just looking at around a 24% general productivity gain in that little process there. Then we're going to move on to design task 4. This is now where they went and they did the attenuation problem and the storage volumes. And this is one of the things that I believe that most of you will find a little bit more valuable. So basically, just to give an idea, that attenuation pond grading, it has to be done in a way that you have to provide adequate storage. because all attenuation points, they need to be, you calculate the amount of stormwater that's flowing from your site, and it has to be able to attenuate a certain amount of water. Now, this may prove challenging with the standard grading tools, because the engineer would need to make challenges and also measure those quantities over and over and over again. You're going to update your attenuation pond feature line, the bottom of the attenuation pond, raise it up, lower it down, and then you're basically going to run your volume calculations over and over and over again until you meet that volume requirement. And this does get quite tedious when doing it manually. So also, the test was done to measure the time taken to complete the task with grading optimization, as well as attaining a storage capacity. So this means that grading optimization does not only run through one iterative process, it actually runs through two. The reason for this is that it would attempt to find the adequate slopes based on the parameters that you do give it, as well as a volume. So it has to run basically through these two iterative processes and then find which design would work best. So there's also another part of grading optimization, and that is called stage storage tools. It's part of the same. It's part of the same add-on, and basically that runs along with your iterative processing to tell you once your new desired volume storage volume has been achieved. So also attenuation ponds are a fairly simple little process. They don't take too much time even when doing them with the standard grading tools, but depending on how many iterations you have to manually run through with the standard grading tools, it might take quite a bit longer. So for this specific example, Autodesk, the guys at Autodesk took around 9 minutes and 50 seconds. And then when using grading optimization, it took around 7 minutes and 53 seconds. And as I said, the reason why there's not as much, there's a 2-minute difference or 2-minute productivity gain, that's around 20%. But the reason why it doesn't save as much time with this specific aspect is because it has to run through those double iterative processes. All right, so that is attenuation points. Then the last aspect, so when looking at those first 4 aspects, those objects or those processes were run each in their own model, and they're not relating to any other information, maybe except for the retaining walls. But now when looking at the design task 5, which is the overall grading comparison, we look at the entire process from start to end. That is going from your overall site grading to your building pads, to your parking area, then into your attenuation pond, your retaining walls, and so forth. All right. So each one of these processes following on each other are based on the previous ones. So this will result in it taking a little bit more time, but this is where we truly start to see how much time the software saves you. So, as I said there, the process is done to measure the time spent on the design of the entire grading project rather than the individual workflow. So not looking at each workflow individually. And then in the case of both methods, it does take longer because each of these designs do or are based on a previous aspect. So when using the standard grading tools in Civil 3D to design that little site that you guys see on the bottom right there, it took around 1 hour, 39 minutes and 6 seconds. But when using the grading optimization for Civil 3D with its iterative processing to get to a nice and balanced design, it took 23 minutes and 22 seconds. And guys, that is an immense difference. That is a productivity gain of 1 hour and 15 minutes and 44 seconds. Or 76% productivity gain. And the guys on here that know Civil 3D will know that that is a lot of time. You can get so much more done on your projects when actually utilizing grading optimization. You can spend a little bit more time on your actual road design and so forth. All right, so that is it for the 5 design tasks. Now we are moving over to just the final results that we got. So basically, to get an average, to basically find out what is the average productivity gain when using grading optimization for Civil 3D in relation to the standard grading tools, we are looking at the time spent in total on the individual processes, that is step 1 to 4, and then adding that to the time spent on the overall grading, which is step 5, which is basically all the individual processes together, but in a actual cohesive design. All right, so adding those two together and then looking at the total time spent. So then looking at the standard grading tools inside of Civil 3D, when doing the individual processes as well as the overall grading added together, it took around, in total, 2 hours, 48 minutes, and 40 seconds. But when adding all of those processes together, the time spent in grading with grading optimization for Civil 3D, it took around 44 minutes and 16 seconds. That is even greater than what we've seen before. So that is a productivity gain of 2 hours and 4 minutes, 24 seconds. That is an average of 73% over these types of processes. And guys, this is not a reflection to say that this is what it's going to take you. This is just as a guideline, approximately on a 16-acre project. This is the amount of time that these guys have saved on their project. And that does, I believe that does tend to show what the software can do, where the power of grading optimization lies. So then, also just to basically put a little bit more attention on it, when doing the manual grading, it does also require a lot more detailed planning, because you need to go and manually adjust every single slope, add in drainage points, low points, and so forth on your surfaces. It does take a lot more planning and a lot more manual input, especially when testing various iterations. All right. And also another benefit of grading optimization is that it does offer a visualization tool. It reflects, it actually happens in front of you as the software runs through all these different iterations. So it actually reflects these iterations as the software moves through them. All right, so you do have that little bit of a benefit on top of it as well. Okay, and then guys, just to finalize, we're going to move over to just looking at the other aspects. So we've been focusing quite a bit now on, the amount of time that the software spends you, but what about accuracy? Okay, so now we're going to look at also, when looking at the overall grading, volume calculations were done for both the manual standard grading tools in Civil 3D, and then volume calculations were done for the on the project where the grading optimization was used. And there is a clear difference. Okay, so one of the main differences comes in that when doing these two processes, you are going to have different end results. Your layouts might be a little bit different due to the nature of it. And also, this will account for the difference in the final earthworks quantities. So then also, let's just quickly have a look at those volumes over there. Now, do note this project was not set. So when the guys at Autodesk were doing this case study, the project was not set to prioritize cut and fill balancing. If it was done, then the resulting quantities would have been a lot more balanced. But let's just have a look at it, even though it wasn't set to prioritize earthworks balancing. With the standard grading tools in Civil 3D, we looked at a finished earthworks cut volume of around 40,000 cubic yards. Do note this is in imperial, not in metric. And finished earthwork full volume of around 240 cubic yards. That is a net volume of around 40,500 cubic yards. All right. And then when using the grading optimization, we had a finished earthworks cut volume of around 3,300 cubic yards, which is already a lot more reduced. That's already less than 10% of the manual methods quantities there. And then when looking at the full volume, it does seem that most of the site is a little bit in full. We're looking at around 13,800 cubic yards of full there, resulting in a 10,500 cubic yard net volume. All right, so we're looking at quite a bit of a difference there. Okay, and that just goes to show how much these iterative processes actually help us at the end of the day. Because as engineers, we can't necessarily be expected to look at our design and run through an earthworks exercise, let's say 20 times even manually. It just takes too much time. It might take you an entire day just to get to an acceptable earthworks volume. And then you don't really get a chance to get to the other aspects of the project. This is now just purely earthworks. All right, so it is definitely worth it to look at grading optimization. It does save you a lot of time, and it already gets you into a lot better ballpark figure when it comes to your earthworks volumes. Now, to get to a more streamlined design at the end of the day, you would probably be using a combination of the two. So you would be doing your preliminary design and your initial calculations by using grading optimization, but you can then still go in afterwards and you can still go and tweak your design a little bit. You can still go and just drop some elevations, balance your earthworks out a little bit and play around with it that way. So in so doing, you can even achieve a better end product than just using either or. So guys, that is basically what I wanted to talk about. So those are the benefits actually shown with time measurements as well as earthworks volume calculations. All right, so I see there are a few questions probably. Let me just quickly get to these over here. All right. So I see Salome did send her details in the chat if anyone wants it. So what versions of Civil 3D is grading optimization available with? I believe it was released initially in 2020. So you should be able to use it in, I believe, 2020, 2021, 2022, as well as 2023. It is a separate download in the Autodesk desktop app. Sometimes if it doesn't show up there, you might just have to go access your complete list of software and download it from there. And it is then available from your tool palettes in the same environment where your assemblies and so forth are available from. Right, I believe they are still updating it for 2023, so I'm not sure if it's available on that one yet. I have not tested that one out yet. All right, guys. So I think that's the only question that I had so far. Are there any other questions, maybe? Does it come at an extra cost? No, it does not. So actually, if you have the Autodesk AEC collection, it is actually included in that package, and you will just be able to download it from your list of software. The recording will be shared, and it will also be available on our YouTube channel. I'll actually just quickly type the channel name here. It's just Modern Art Design Centers. So Modern Art Design Centers, that is our YouTube channel name. All of our previous webinars are also available on there, and you can watch them at any time. Okay. Does the software also assist with grading around bridge abutments? Yes, it actually does. There's actually a facet of the software. I don't have an image of it right here, but there are videos available showcasing that it actually does have a function purely for bridge abutments. And I myself was quite impressed when I saw how well it handled that. Okay, I see there's another question here. Is there a manual for grading options only? So it is actually available on the online help file. I believe that's currently the only actual manual available for it. So if you go to the Civil 3D help file or online help file, you will be able to see all of some videos and some guiding documentation for the software. I also see there's another question here from Shark. What is your area limit? Well, I believe that currently the area limit for grading, I don't think there's really an upper tested limit. It would probably be around the same as your, okay, so let me explain it this way. So sometimes grading optimization, the name of the software might be a little bit misleading. It doesn't physically make use of gradings. So in the end, you know, when you do, for example, just a basic platform, you have your feature line, you run your grading around the outside, that is an actual object. Whereas when you're using the grading optimization tool, it creates feature lines from your polylines and it adds them as break lines to your surface. It then just runs through iterations of changing the slopes on your feature lines and so forth. So I think the upper limit for this grading creation would probably be around the same as the upper limit for surfaces. Okay. See, there's another question here from Eric. What of areas where you need to balance the cut and fill? What of areas with cut to spoil, clay, or imported fill? Okay, so basically for that, that would be up to your personal judgment. I mean, even when using the standard Civil 3D grading creation tools, there's not really a way for you to say to it, listen, okay, you know, this part of the surface is unusable material that has to go to spoil. So you would kind of, there's a workflow with doing it with normal gradings, but I would have to play around with it a little bit more to have a look at that. All right. Okay, guys. Let me just have a look here. Q&A again. Okay, it was only this one. Right. Okay, so guys, if there aren't any other questions, then I'm going to say enjoy the rest of your day and thank you guys for joining. I see the iterations report available. It does give you a live report of your software as you, or sorry, of your project as you go through the different iterations. All right. Okay, guys, thanks for the questions. I'm going to end the session here. Thank you for all your questions. It was really wonderful, and I hope to see you guys next time. Cheers.